Hi, I'm Instructor of secondary one for NS High School. Right now here is a lesson 4, ordinary differential equations. Well, in this part of ordinary differential equations, I'm going to show you something special using the operators method. So first of all, let me just tell you, in this case we're dealing with sines and cosines. And if you have learned your differentiation properly, sine differentiates to a cosine, cosine differentiates to a negative sine. So the first thing that we have to be clear of is what if our y is a sine, then you can say it's a ax, then you have add b cosine ax. Like, you just give this as your y. So let's try a little bit. We try to go for first order differentiation. So the first order, you'll realize you have an a taken out from here, and also an a taken out from here, which is according to the chain rule. So that means you have an a on the outside. But wait, sine differentiates to a cosine. And then cosine, this part, it differentiates, you get a negative sine. Alright, so this is what happens in your first order differentiation. Then for your second order, so from the second part, you could take out an a again from chain rule. Then cosine, you differentiate, you get negative sine. Well, negative, here the negative still remains. So that means you could have a negative a squared. So that means from here cosine, well, that means it becomes sine. Just because the negative is taken out. So this negative is taken out, then you add b. So here it becomes cosine. So this is what happens. Then let's take a look at our original y. So our original y, a sine ax plus b cosine ax. And this part, we have a sine ax plus b cosine ax. So then this part, you could just write it as negative a squared y. So you could just write it like this. So at first, y, after the second time of differentiation, you get, it's just like it just times a negative a squared. It's just like that. But you have to make sure coefficient of x, they're all a. Then let's just keep on trying. Third derivative. Third derivative, what will we have? So we just have to differentiate this again. And a come out negative a cube. Then from this part you have a cosine ax. So cosine negative b sine ax. Then wait, what if we compare with the ones above again? You realize these two parts, they are the same. So you could also write it as a negative a squared dy. So this happens when you have to differentiate two times again. So let's just try one more time until the fourth differentiation. Let's just try again. So cosine negative, sine cosine, okay, still a negative. So that means here will become positive. Or a's, you can take them out and you get a to the power of 4. And so inside here, a sine ax. Since cosine, you get negative, but the negative is taken out so that it becomes positive. Then you have plus b cosine ax. Then when you first compare it with the ones above, you realize, wait, I could just write it as negative a squared d squared y. I could write it like that. Then you compare it with the first ones. Or you could also write it as a to the power of 4 y. So you could write it these ways here. So actually, from here you can already find a pattern. And so this goes on. It is just times a negative a squared for every second differentiation from those that you get. So right now, for this pattern here, we have already cleared it. So what if I just give like a d cubed, then you subtract 2d squared, then you add d, then you add 3, then y, and this part give it as equal to, let's just take the simplest part, sine ax. So let's just take it like this first. So from these operators, the first part that you give will be y equals sine ax over d cubed subtract 2d squared plus d plus 3. But wait, at this step, you may not know how to continue, right? So according to what you have done before, or what you have integrated out of sine, what you will always get, you do have a sine function here, and at the same time you also have a cosine, and the coefficients we don't know since we didn't actually solve it, so we can just leave it as a and b in this form here. So let's take a look. What if I put this up there again? So what if I did that again? Let me see. What if I did this? So wait, now I know that y can be transferred into this thing here. And then as from what we have done just now, it follows the same pattern. So let's see. d cubed, okay, d cubed from this part, you can just change it into negative a squared, then d. Beware, this is only a d, because here we have extra y, and this part, the y is taken out. Alright, so negative a squared d. Then d squared, okay, so you have plus 2a squared for this part. Alright, then after that for d, okay, you just remain as a d, then you add 3, then y for this part. So if we just take away the y, if you take away this part, you compare it with above again, what do you see? What kind of same thing you see? So you'll find that these are the same. Well, it's because that we just we think that we times this to the other side. So these are the same. That means we could just replace this part with this. So when we replace them, and so it becomes this part. And this is your y. So what if we just rearrange them again? Okay, we just rearrange so that it can look more nice. So in this part where we rearrange, we just put these together, and those that don't have these together. Okay, and this is the part that we get. So in this lesson here, well, we're just going to use this to try it out. So how about let me just give an exact example, but still with this. If not, we have to find the whole thing again, okay? So just using here, let's say we give sine 3x, okay? So according to this that we will find, it is y will be equal to, okay, sine 3x still, then over. So now your a is 3, so your a is 3, a squared, 9 times 2, you get 18. Then 18 plus 3, you get 21. After that, is going to add, wait, let's try it first. So 3, negative 9, negative 8. No, it's not add. This is subtract. So you need a minus 8d. So this is the part that you're having. Then let's just think, this is an a minus b. So if we just times the a plus b on both sides. Wait, but we have actually proven that a few lessons ago. It's just differentiate and integrate. Differentiate, integrate, using both orders, yes, they're still the same thing. So, as proven in that lesson, we could use this. So that means we can use 21 plus 8d. So here you get 21 squared. Then you have to subtract 64, or you can also remain it as an 8 square. Then d square at this part. And this step, it still look like that you only have a sine 3x there. In the next step, you'll get cosines. Okay, how? So sine, first of all, you times this constant. Okay, 21 sine 3x. Then for the next part, 8d. 8d. So you have to start differentiating. So you differentiate this part, you get cosine. And chain rule, you get 3 outside. So then you have 24 cosine 3x. So from this part, 21 squared, if you could remember that, it is 441. So 441, then, okay, you can just write it down. Then subtract, okay, 64, you get a d squared. So from here, you could just take it as a negative a squared. Negative. So a squared that you're using here is a 9. So that means 64 times 9. You can just use, okay, so 64 times 9 will be 576. Then what you will get will be 1017. So in your denominator here, 1017 will be what you get, okay? But this looks good enough. Can we continue to simplify to make it even better? If you have realized that, you here, multiple of 3, here's a multiple of 3, below, 1 plus 1 plus 7. According to, well, the divisibility by 3, yes, this is also divisible by 3. So if you want to simplify it even more, you can use 7 sine 3x plus 8 cosine 3x, then over 3, 9 for this part that you'll get, alright? So here will be your y, finally. But it's the first time that we're using this. Can we just directly say this is true? Wait, how about let's check about it. We can use it to, we can verify it right now, okay? So from this part, let me just write down that question again. And this question, which you have, d cubed subtract 2d squared, add d, then you add 3. Then this d is differentiating for y. And then it's equal to sine 3x. So this is the question that we had. And this is our solution. And then just write that above. So our solution, y equals 7 sine 3x. Then you add 8 cosine 3x. Then over 339. Okay, so this part can erase. Then next, let's take a look at the solution that we get. So when you put it inside to differentiate, so the part that we don't need it to differentiate is this constant below here, which is over 339. So 1 over 339, we can just take it out first, alright? Then you get d cubed subtract 2d squared, then you add d, then you add 3. Then in this part will be differentiate for 7 sine 3x, then you add 8 cosine 3x. Then let's take a look at what we'll get. So 1339 is still there. Okay. Then how about from here? We just differentiate this part first. wait, but this looks like that. Because we need this one whole chain, so I'm just going to write it down here. And wait, this part, when we're checking this answer, the process that we call it is verify or verification for the noun. Okay, so this is the part that we verify. So during this verify, okay, 1/339, still up here or down here. Then afterwards, so we differentiate this part first. dq, then you will get, for this first part, this first part will be, so let's just take a look. Sine, you differentiate 3 times. Sine, you get cosine, then negative sine, then negative cosine. So negative cosine 3x. Then you have 7 times, okay, 3 to the power of 3, since you differentiate 3 times, so there will be 3 of the 3's coming out. So 7 times 27 will be 189. Then afterwards, you have d cubed on cosine 3x. So d cubed and cosine 3x, what you get will be. So let's just take a look. Cosine, you differentiate 3 times. You have negative sine, negative cosine, then positive sine. So you have plus sine 3x. Then 8 times 3 to the power of 3, which is 8 times 27, which you can just take it as this part, 189, then you add 27, which will become which will be 216. So this is for the first part in d cubed. The next will be for the part in d squared. So negative 2, d squared, for this first part, sine, you get cosine, then negative sine. So negative sine, negative, positive sine. Okay? Then 2 times 7 times 3 squared. So which will become 14 times 9. And 14 times 9 will be 126. 14 times 9. Alright? So this is the part that you're having. Then for this part behind, cosine, which you differentiate 2 times, is negative sine and negative cosine. Negative cosine, negative, get positive cosine 3x. So then you have 2 times 8 times 3 squared, which you can also add 18 to this part, which is 144. Or you can also directly calculate 16 times 9, which is exactly, so 16 you can break it down into 4 times 4, 9 becomes 3 times 3, then 12 squared. So that's the part you get here. The next, for this d, then you just differentiate once, simple. So sine, you get 21. Okay, and let's add 21 cosine 3x. Then from here you need to subtract because of this cosine. Subtract 24. Then you have sine 3x. Then for the last part, which are constants. So 21 sine 3x, then you plus 24 cosine 3x. Okay, so this is the whole chain that you get. So let's take a look at the parts. Cosine, 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 and cosine here. So what do we get? So that means you need to find negative 189 at 144 at 21 at 24 for this part. Okay, so that means it will give you a 0. So cosine part, you won't have it. So the last parts are for sine, which actually only have 2 parts. So it will be 216 plus 126. Then you subtract 24 and then add 21 for this part. Okay, so let's take a look. So from the first part will be 3, 4, 2. After you just subtract 3, because these 2 parts, well, you can just calculate that directly, which you get 339. Wait, 339. 1 over 339, that means you get sine 3x. Alright. So here we have verified it. Alright. So this part already verified. That means this solution that we get is correct. Alright, so that's the part that we have in this lesson. So, just to tell you again, the first part where you get this equation, you can just directly change these operators. Well, according to these sines and cosines, yes, you can change them. So for every square, you change them into negative a square. Then change them to negative a square. At last, when you get your exact value for a, you can just plug in these answers, then you'll get your solution. And here we have already proven it is right. So I will end this lesson here. And if you like our videos, don't forget to subscribe to our channel. Thank you for your watching.